So today, we're going to dive into a really fascinating kind of AI. We're talking about a system that doesn't just look at our world, but actually learns what it's made of. You know, its essence. It can clean up the messy parts and even generate brand new realities completely from scratch. Let's jump right in.
You know, it really all kicks off with this one, kind of mind-bending question. How on earth can a machine dream up a face, or a piece of music, or a block of code that's totally new, but feels completely real? Well, to get that answer, we actually have to start with an AI that's an expert at, well, copying. Okay, so let's meet the Autoencoder. Now, I want you to think of it like a master forger, but, a forger for good. Its entire job is to create a perfect, flawless replica of something. But here's the catch. To do that, it first has to understand the most basic, most essential features of the original. And that's where the real magic starts to happen.
So what is this thing technically? An autoencoder is a type of neural network that pretty much teaches itself. That's the unsupervised part. It doesn't need a bunch of human labels. It really has two main components. An encoder, which takes data and compresses it into what's called a latent space. You can think of that as a super compressed secret code. And then a decoder, which has to try and uncompress it. The whole point of the exercise? To get back exactly what you started with. All right, so here's how it actually works. The encoder takes an image, let's say it's a picture of a cat, and it just squishes it way, way down into this tiny compressed code. This bottleneck is super important because it forces the network to throw away all the noise and focus only on the most critical features, the stuff that really screams cat. Then it's the decoder's turn. Its job is to rebuild the original cat photo using only that tiny compressed essence. And this right here is the absolute key. The whole system learns by trying to minimize something called reconstruction error. It's like it's constantly asking itself, okay, how different is my copy from the real thing? Every single time it makes that difference smaller, it gets smarter. It gets better at understanding the deep, fundamental patterns of whatever it's trying to copy.
So you might be wondering, what's the big deal about creating a perfect copycat? Well, it turns out that being forced to find those essential features is an incredibly useful skill. You can use it for some seriously powerful data compression, for cleaning up old, grainy photos. That's a process called denoising. And even for spotting when something just doesn't fit. And this is where it gets really clever, because this ability turns our little copier into a pretty powerful detective. Imagine you train an autoencoder on, say, thousands of totally normal everyday bank transactions. It gets really, really good at copying them. But the second you feed it a fraudulent transaction, it struggles. It can't make a good copy. That reconstruction error just shoots through the roof, and bam, you've just flagged an anomaly. It's a copier that's fantastic at finding things that just don't belong.
Okay, copying is cool. But what if we want to go beyond just copying what already exists? What if we want to create something totally new? See, the problem with our master copier is that its secret code for an image is just one fixed point. You can't just pick a random code and hope for a good picture. It just wasn't built for that kind of creativity. And this brings us to the next step in the evolution, the Variational Autoencoder, or VAE. This is where the AI actually starts to dream. Now, the difference here, it sounds small, but it is absolutely massive. A standard autoencoder learns a single, rigid blueprint for how to compress data. But a VA? It learns a flexible map of possibilities. It learns a whole range of potential features, not just one specific set.
So, to get a little technical for a second, a VAE is what we call a generative model. Instead of squishing an image down to one single point, it squishes it into a distribution. Think of it like a little cloud of similar possible points in that compressed space. And what that means is that it can then just pick a random point from that cloud to generate something completely new.
And this is how we finally answer that first question. By picking a new spot on that map of possibilities, the VAE can tell its decoder, hey, create a face from this. And the face it creates will share all the essential features of the real faces it learned from, but it'll be a unique combination, a person who never ever existed. It's not just copying anymore, it's actually creating.
Now, VAEs are amazing dreamers, but sometimes their dreams can be a little blurry, a little fuzzy. To get those hyper-realistic results, researchers came up with a totally different idea. Let's set up a high-stakes competition. This is a whole different ballgame. Enter the Generative Adversarial Networks, or GANs. This isn't about copying or mapping. This is about a relentless, cutthroat game of cat and mouse.
So, a GAN has two key players, two neural networks, locked in a battle of wits. First, you've got the generator. Think of it like an art forger, and its only job is to create perfect, convincing fakes from nothing but random noise. Its opponent is the discriminator, who is like an art detective. Its only job is to look at a piece of art and decide, is this a real masterpiece, or is this one of the forger's fakes?
Okay, so the game goes something like this. The generator makes a fake. The discriminator looks at it along with a bunch of real images and makes a judgment. Now here's the really important part. The discriminator then gives feedback to the generator. It basically says, nice try, but here's how I knew you were faking. The generator takes that feedback and tries to make a better fake next time, and at the same time, the discriminator learns how to be an even better detective. They literally force each other to get better and better.
So you can see their goals are in total opposition, right? The generator only wins if it can fool the discriminator. The discriminator only wins if it catches the fake. This constant push and pull, this adversarial pressure, is exactly what forces GANs to create images that are just shockingly photorealistically real. All right, let's take a step back and put all these pieces together. We've gone on quite a journey here, right? We started with a simple AI that learns just by making perfect copies. Then we moved to a more advanced one that creates by exploring a map of ideas, and we ended up with a system that generates mind-blowing reality through pure head-to-head competition.
So here's a quick little cheat sheet just to keep it all straight. First up, the standard autoencoder. That's your master copier. It's perfect for cleanup jobs like denoising images and detective work like spotting anomalies. Then you've got the VAE, your creative dreamer. It uses that probabilistic map to generate new stuff that's similar to what it's seen before. And finally, the GAN. That's your hyper-realistic artist, using that adversarial game to create incredibly convincing data. Each one has its own special talent.
And all of this, from copying to creating, leaves us with a really big, really important question that goes way beyond the technology itself. When artificial intelligence can generate a reality that is perfect and indistinguishable from our own, how will we ever know what's real?